What we're going to be looking at in this example is the distinction between marginal physical product and the marginal cost of production. So what we're going to do is assume that we have a person who owns a burrito stand and they have fixed cost of $50 per day, and each laborer that they hire is going to be paid $50 per day as well. So to go in and do our calculations, we're going to need about 5 columns of information. The first is going to be the quantity of labor that is going to be hired, and then we're going to have the quantity of output, which we will just put Q for that. And then we're going to go in and calculate our marginal physical product of labor. In the fourth column, we will have our total cost. And in the last column, we'll be calculating our marginal cost. Okay, a couple pieces of information that we need to know. First of all, we're going to have only up to 5 workers that can be hired. So we'll put 2, 3, 4, and 5. And then as we go through and we watch these workers produce, if we have 0 workers, clearly we're going to get 0 output. But then we notice the first worker we hire, we get 25 units of output, 75 units of output with 2 workers, 100 with 3 workers, 110 for 4 workers, and then if we have 5 workers all producing, we will get 115 units of output. All right, now again, we are going to assume that our total fixed cost is going to be $50, and each unit of labor is going to be equal to $50 per day as well. All right, now to go in and calculate our third column, which is the marginal physical product of labor, what that is telling us is how much more output do we get when we go in and we hire a unit of labor. Now you notice the way I have labor set up, our change in labor is going to be equal to 1. So our marginal physical product of labor is simply going to be our change in quantity. So if I go in and I hire 1 laborer, we calculate delta Q as being the change in quantity at time period 1 minus the change in quantity at time period 0. So we would have 25 minus 0 would give us 25. So our first worker would give us an additional 25 units of output. 75 minus 25 is going to give us 50. So remember, we're looking at additional units, so our second laborer will give us an additional 50 units of output. If we hire the third worker, 100 minus 75, we get 25 units of additional output. If we hire the fourth worker, 110 minus 100 gives us 10. And then our fifth worker, 115 minus 110, is going to give us only 5 units of additional output. All right, now our total cost, since we know our total fixed cost is going to be equal to $50, regardless of how much we go in and produce. So that means that if we do no production whatsoever, then we're going to have to go in and pay $50 for our equipment. All right, our total cost then, if we go in and we hire our first worker, so worker number 1 is being paid $50, plus we're also paying $50 of fixed cost. So our total fixed cost plus our total variable cost is going to end up equaling $100 of total cost, 1 labor and 1 unit of fixed cost. If we hire 2 workers, each one of those making $50, so there's $100 worth of labor plus your $50 of fixed cost, so there's $150 of total fixed cost. If we hire our third worker, there's $150 of labor plus $50 of fixed cost, so that's $200 in total cost. Our fourth worker will yield $250 in total cost. And then our fifth worker, 5 times 50, is going to give us $250 of labor plus our $50 of fixed cost. That will give us $300 in total cost. Okay, what we want to do now is go in and calculate our marginal cost. Our marginal cost is always found by taking the change in our total cost divided by our change in output. So when we go in, and in this case, if you notice, we've already calculated our change in output to be our marginal product of labor. So in this case, we're going to take the change in total cost divided by the marginal product of labor. The marginal product of labor. All right, because the marginal product of labor we know to be our change in quantity. So let's go in and let's calculate it if we go in and we hire our first worker. All right, our change in total cost for hiring our first worker is going to be 100 minus 50. All right, so our change in total cost is going to be $50 divided by the marginal physical product of labor for our first labor, which is going to be 25. So to go in and hire our first worker, 50 divided by 25 is going to give us $2. All right, so our marginal cost, our additional cost of going in and hiring that worker is going to be $2. All right, so if we go in, for the sake of argument, if we look at the marginal cost of hiring the second worker, so our marginal cost of worker number 2 is going to be equal to our change in total cost of worker number 2 divided by our marginal physical product of labor, right, for worker number 2. So if we go in and we take 150 minus 100, so that's going to give us a change in total cost of $50, divided by our marginal physical product of labor, which is going to be $50. So 50 divided by 50 is going to give us $1. So our marginal cost of producing the next unit of output is going to be equal to $1. And then so it goes. You would have 200 divided by 150, which is going to give us 50. And then 50 divided by 25 is going to give us $2. 250 minus 200 will give us $50. 50 divided by 10 is going to give us $5. And then 300 divided by 250 will give us 50. And then 50 divided by 5 is going to give us a marginal cost of $10. So what you notice is, in this case, if we go in and we hire workers number 1 and worker number 2, that our marginal physical product actually increases for both of those workers, while at the same time our marginal cost falls. But then what happens is, when we go in and we hire the third worker, the additional output that third worker gives us starts to fall. As we hire our fourth worker, it falls even further. And then as we hire our fifth worker, they're only adding an additional 5 units. While at the same time, the cost of producing that output is starting to rise quite dramatically. So the way you can show that trend is then when you go in and you graph both of these together, you would have the marginal physical product of labor, and that is over the number of workers that you have. And then in this graph, we are going to go in and plot our total cost, and our total cost is going to be plotted against output. So for our marginal physical product of labor, again, you notice it rises dramatically and then it falls off very quickly. So your marginal physical product curve is going to look something like this. Marginal physical product of labor. Whereas when you look at your marginal cost curve, your marginal cost declines for the first 2 workers or the first 2 units of output, and after that it starts to rise dramatically. So what you would see for your marginal cost is your curve looking something like this. So again, all of this hinges on your 2 equations, the marginal physical product of labor and your marginal cost.